అర్థమైంది మ్యామ్ మిమ్మల్ని కూడా చూసి.
అదే అప్పుడు టైం టేబుల్ వేస్తా అంటున్నా, 7th రోజు వేస్తా టైం టేబుల్.
ఓకే మ్యామ్.
This timetable, ma'am, which they sent now.
అందరు అప్పుడే స్టార్ట్ చేస్తారంట మ్యామ్ చదవటం.
అవును మ్యామ్, అప్పుడే స్టార్ట్ చేస్తాం మ్యామ్.
ఎందుకు
వన్ డే బ్యాట్స్మెన్ మ్యామ్.
ఇప్పటి నుంచే స్టార్ట్ చేయండి.
ఇంట్లో చదవ బుద్ధి కావట్లేదు మ్యామ్.
మ్యామ్ కాలేజ్ లో చదవడానికి
మండే నుంచి రండి అందరూ, సరేనా?
ఎస్ మ్యామ్, చూస్తాం.
చూస్తాం చేస్తాం కాదు, మండే నుంచి రావాలంతే.
కోవిడ్ కేసెస్ పెరుగుతున్నాయి మ్యామ్.
అవన్నీ మీకు పక్కన పెట్టండి, మీ దగ్గరికి ఏం రాదులే కోవిడ్.
ఫోర్స్ చేయదని చెప్పింది మేడం హైకోర్టు.
అవ్వట్లేదు మ్యామ్.
హైకోర్టు నుంచి ఆర్డర్ వచ్చింది మేడం, ఫోర్స్ చేయకండి అని.
ఏం
కుదిరితే వస్తాం
మ్యామ్. చైనా వాళ్ళు ఇంకో రోగం తెచ్చారు మ్యామ్, అందుకే.
చాలండి, మీరైతే
మ్యామ్ వీళ్ళందరూ మీ టైం వేస్ట్ చేస్తున్నారు మ్యామ్. క్లాస్ స్టార్ట్ చేయండి మీరు.
స్టార్ట్ చేద్దాం. కాదు, శానిటైజర్ బాటిల్ కొనుక్కొని, మాస్క్ కొనుక్కోండి, శుభ్రంగా బాక్స్ పెట్టుకొని, లంచ్ బాక్స్ పెట్టుకొని రండి. అర్థమైందా? బుక్స్ తీసుకోండి.
మ్యామ్ శానిటైజర్ కూడా కొట్టేస్తున్నారు మ్యామ్ క్లాస్ లో.
పేరు రాసుకోండి.
కాలేజ్ లో ప్రొవైడ్ చేయరా మ్యామ్ శానిటైజర్?
పేరు రాసుకోండి అమ్మా. శానిటైజర్ ప్రొవైడ్ చేస్తారు, యూజ్ చేసుకోండి. ఇక్కడ
ఫ్రీ మ్యామ్, ఫ్రీ ఆఫ్ కాస్ట్.
ఫ్రీ ఆఫ్ కాస్ట్. సరే, క్లాస్ స్టార్ట్ చేద్దామా? till which question we completed, tell ma. హలో,
ఆక్సిడేషన్ కరోషన్.
అయితే 11th క్వశ్చన్. ఓకే
లేదు మ్యామ్, 14th వరకు అయిపోయింది. ఎలక్ట్రోకెమికల్ కరోషన్.
సో 15th క్వశ్చన్ we have to discuss, no?
Yes ma'am.
So okay, describe the role of nature of oxide formed in oxidation corrosion. Okay, state and explain filling Wentworth rule. So students, here you write nature of the oxide formed, means oxidation corrosion only you have to write here, and types also you write. Okay na? So what are the types are there, so that you write filling Wentworth rule. Question framing is different, but the same answer, because we have to frame the questions, 20 questions, no? So we'll get the questions more, but answer will be, so what you are learning, that only you have to write. Okay, here you write oxidation corrosion plus the types of metal oxide layers, then filling Wentworth rule. So that is 15th one. 16th one, describe the process of galvanization of iron. So galvanizing process already we learned. Okay, so that you write here, describe the process of galvanization of iron. How does it prevents the corrosion of iron? Okay, and mention its applications. So students, you have to learn the diagram first here. Okay, diagram how to learn. So from the diagram only you can write the theory part, then you can write the applications. So I think 5 or 6 points we can write in galvanization process. So first we will take here iron sheet, and we will wash in dilute H2SO4. So to remove the impurities present on the surface of the iron sheet, then we are passing into the washing bath. We will wash completely iron sheet here with water. So then we will pass that sheet to drying chamber. We will dry it. After drying, we'll pass it to the molten zinc bath covered with the ammonium chloride flakes. So from there we will pass this iron sheet. After passing into the molten zinc, then we'll pass through a pair of hot rollers to remove excess zinc present on the surface of the iron sheet. So then we will pass that iron sheet, we'll go for annealing process, okay, where we maintain the temperature 650 degrees centigrade, so that we get here any internal stains are there on the surface of the iron sheet, we can remove it. So we will get a uniform thin coating of zinc on the surface of iron. So galvanized iron sheet, so that we will make, means we are getting a coating of zinc on the surface of iron sheet. So write that students process and write applications also. Next, 17th question, explain the process of tinning. So same here, galvanization process like same like this, means diagram will be not same, it will be different. Here you have to use the tin here. Before we used zinc, here molten tin we will take, molten tin, and covered with the zinc chloride flakes. So we are passing iron sheet after cleaning, after drying, after cleaning and drying. we will pass through the molten tin covered with the zinc chloride flux. Then we will pass through the layer of palm oil to prevent here oxidation of the tin coating, and then we will pass through the rollers, and we go for annealing process here also, but in diagram we are not showing that one. So how I have given diagram, you learn that only and write the process and applications. And next, what is cathodic protection? Explain the sacrificial anodic protection method of controlling corrosion and write its applications. So first write now what is the principle of cathodic protection. So how we are selecting the metals to control the corrosion. So we'll take the base metal, and to the base metal we are connecting the other metal which should be more anodic to the base metal. It should be more anodic to the base metal, so that the more anodic metal, it will undergo oxidation reaction. It will lose electrons. So that electrons are gained by here base metal. It will act as cathode. So that type of protection is called cathodic protection. So then you take here what one process only asked here, one type, sacrificial anodic protection method. So in this, what we do, we are taking the base metal, okay, for example iron, we are connecting to the with the copper wire, we are connecting to the other metal which is more anodic to the iron. Follow the electrochemical series, so we can connect more anodic metal to the base metal, so that we can control the corrosion in means we can protect the base metal without undergoing corrosion. Okay, write some applications. So long pipes you can take, water tanks you can take, ship you can take. Some examples you write applications. Next, 19th question. Explain the impressed current method of cathodic protection with a neat diagram and write its application. Students, you have to learn the diagrams compulsory. Okay, wherever the diagram is there, see sacrificial anodic diagram will be there. Tinning diagram, galvanization process diagram, impressed current diagram is there, electroplating diagram is there. So wherever the diagram is there, you have to learn the diagram perfectly. You have to draw neatly. Okay, label it, draw neatly. Then you have to learn the reactions. So in electroplating, the reactions are, learn the reactions, and you have to write the reactions, write the theory part. Okay. So what, explain the impressed current method of cathodic protection. So here what we are doing is, here also we are taking a base metal, and to the base metal we are taking the other metal like a graphite. Okay, we are taking inert metal we are taking, and we are connecting to the DC source. So we supply external current here, and will convert corroding metal from anode to cathode, and will protect the base metal. Next, 20th question. Illustrate the reactions involved in electroplating of copper with a neat diagram and write the advantages of electroplating. So you have to explain here with a neat diagram. You have to learn the diagram, explain the process of electroplating, and write its advantages. Advantages already I have given you. Both metals, we will go for electroplating, and non-metals also. You write the advantages. Okay. So that is part B. So part B, how many questions are there? Part B, 9. So 10 questions are from electrochemistry. Okay. 10 questions are from electrochemistry. Then 10 questions are from corrosion. Hello students, you are there? Hello?
Yes, ma'am.
10 questions are from electrochemistry, ma. Okay. From part B. Part B only you have to prepare. Okay. So 10 questions are from electrochemistry, 10 from corrosion. So we will discuss part C. Part C, 6 problems are there. Okay. And 3 analytical questions are there. Okay. 4, 3. 3 analytical or 4 analytical, 4 analytical questions. We'll discuss. So this problem, students, already you know how to do, you know the formulas also. Now tell ma how to calculate the here EMF of the cell. What is the formula ma for first problem? Hello students. Hello students, tell me what is the formula for first problem. Calculate the EMF of voltaic cell. Electrode potential of copper and iron are 0.34 volt and
E
minus
cathode minus E anode.
E cathode minus E anode. Okay. So here in this, which is cathode, which is anode? Given electrode potential of copper and iron. Copper is
Cathode.
cathode. Iron is anode. Okay. You can apply the formula. You will get the answer. Okay. Na? So here we applied formula E cell is equal to E cathode minus E anode 0.34 minus. So in brackets minus 0.44, 0.34 plus 0.44, answer is 0.78. That is the first problem. Students, you are having problems in your notes, no? Hello.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Second also same problem. Here calculate the EMF of the cell.
E cathode minus E anode, ma'am.
Cathode minus E anode. Same. See here 1.1. E cell is equal to 1.1. So some students, they won't do this simple problem also. Very simple problem also they won't do. Students, you have to do this problem compulsory if you get, so that you will get 3 marks. Okay, na? E cell is equal to E cathode minus E anode. So you know the reduction potential values, ma. Okay. Reduction potentials of the cell are, they didn't mention the cell like a zinc and copper, just to given the values minus 0.763 plus 0.337. By looking at the potential values only, you can tell which is cathode, which is anode. Okay, na? You apply the formula and find out the answer. E cell is equal to 1.1 volt. Now third problem, fourth problem. So that is half cell, ma. Nernst equation. Hello.
Yes, ma'am.
Nernst equation, ma. Half cell. These two are half cell. Okay, na? Third problem. Calculate the electrode potential of copper wire dipped in 0.1 molar copper sulfate solution at 25 degrees centigrade. So standard reduction potential of copper is given plus 0.34. Okay.
E naught is given.
E naught is given. Students, from part C, you will get 3 marks questions, ma. Okay, 1B, 2B, 1B, 2B. Okay, you will get from part C only. Means out of these 10 questions, means you are going to get 2. Following me? Hello. Hello, students.
Yes, ma'am.
Out of these 10 questions, how many you will get for CIE 1?
2, ma'am.
2 you will get. Okay, na? Okay. Now we have to calculate the electrode potential of copper wire. Ma. Everybody, you know the Nernst equation. Just to tell me, Nernst equation E cell is equal to. Hello.
E naught cell minus.
E naught cell minus
0.0591 by N.
0.0591 by
N.
Or else we can take like E naught plus 0.059 by N log concentration of the metal.
You can take, no problem.
Yes.
Concentration of the product by concentration
Depend
of the reactant.
log activity of the product by
Activity of the reactant.
activity of the reactant.
Activity of the reactant.
Third problem. See, students, third problem. E cell is equal to E naught cell minus 0.0591 by N log. So 1 by concentration of, okay, we are taking Mn plus 1 by concentration of Mn plus. So we got the concentration here is in the problem. Problem is given already. Okay. So 0.1. So apply that values in the formula. Okay, na? E cell is equal to E naught cell minus 0.0591 by 2 log 1 by 0.1. You will get the answer, ma, 0.34 minus 0.03. Okay. So answer is E cell is equal to 0.31. Okay. Compulsory. You will get this. Okay. 2 questions you will get from part C. Learn everything, all the problems and the theoretical question. Now, fourth one, calculate the electrode potential of zinc rod zinc rod dipped in 0.1 molar zinc sulfate solution at 25 degrees centigrade. Standard reduction potential of zinc is minus 0.76. Students, this same like a previous problem only. Okay. So apply the Nernst equation and do. So this I didn't give in PPT, but in your notes it is there. Okay, na? It is not there in PPT. Okay, na? Hello. Students, answer you tell ma. Hello. Fourth problem answer you tell me. You have done in your notes. అసలు ఉన్నారా లేరా క్లాస్ లో? హలో స్టూడెంట్స్.
Yes, ma'am.
Fourth problem answer you tell me you have done in your notes class work. Hello.
Ma'am, 0.79 volts.
Ma'am, minus 0.789.
Minus 0.79.
79. Okay.
Yes, ma'am.
So 4 problems. Ma. Next fifth one is fifth and sixth is an Nernst equation we are taking for total cell. Okay, na? So fifth problem, the standard reduction potential of zinc and
Ma'am,
copper.
E cathode E anode la find cheyali.
Here you have to find out.
Appudu-
For that you will get 2 marks. See the problem. You
Half
have
cell la find out cheyali
You
kada.
have to find out compulsory E naught cell. They have not given E naught cell. For this you will get 2 marks. For this you will get 5 marks for SCE exam. For now, if you get this problem for 3 marks, I'll give definitely for this I'll give 1 mark. For this I'll give 2 marks. Okay, na? Okay. So you have to find out E naught cell compulsory. Okay. So standard reduction potentials of zinc and copper are minus 0.76 and plus 0.34. What is the EMF of the cell? Okay. Then find out here by applying Nernst equation. You know they have given concentrations to us. Okay, zinc ZnSO4 that is 0.05 molar and copper sulfate Cu2 plus 7 0.005 molar. Apply the Nernst equation total cell. Okay, E cell is equal to E naught cell minus 0.0591 by n log. So activity of the product by activity of the reactant. So we are taking Zn2 plus by Cu2 plus concentration of Zn2 plus concentration of Cu2 plus. Apply the values. Okay. So you will get the answer is E cell is equal to 1.07 volt. So this is the answer. Okay. Hello. Hello. Making noise. Who is that? ఎవరమ్మా నాయిస్ చేసేది? Okay. So next is sixth problem. So we have to sixth problem. What is the overall cell reaction for? Okay, overall cell reaction you have to write. Zinc and silver electrodes are given. Okay, taking in zinc sulfate and silver in silver nitrate, and you have to write the cell reaction. Okay, after writing cell reaction, you have to find out the EMF of the cell. But this electrode standard EMF of the cell is given wrong here. Okay, 1.56. 1.56 in the PPT it is given wrong. 1.56. Okay, na? So you do the problem and write the answer. So this problem also similar like a previous only. Okay. So apply the Nernst equation. E cell is equal to E naught cell minus 0.0591 by n log product by reactant. Okay. Apply the concentrations here 0.2 by 0.002. Okay. So you will get E cell is equal to, what is the answer you got students for sixth problem? Hello. Hello students. Tell me ma, what is the answer you got for sixth problem? Hello.
Ma'am, sixth or fifth, ma'am?
Sixth ma, not this is sixth problem.
Sixth I got 1.4011.
This is sixth problem ma, sixth problem.
1.4011.
1.404011.
Yes, ma'am.
You have taken standard EMF of the cell 1.56 only. Hello.
1.
Because zinc
1.54 అని ఉంది మ్యామ్ క్వశ్చన్ లో.
question లో 54 ఉంది. Okay. Now see, zinc electrode potential is minus 0.76 and silver is plus 0.80. How much we will get? Tell me now. Hello. Find out T naught cell. Minus 0.76 plus 0.80. How much you will get, ma? Students. Hello. You are there? Hello, students.
Yes, ma'am.
Tell me. I got 1.56 E naught cell. How much you are getting?
1.56.
If you take 0.79, 0.79 plus 0.76. 1.55, no? Hello.
Yes ma'am, 1.55.
Okay. You take 1.56, ma. 1.56. Silver electrode potential will be, in some books it is given 0.79, some books 0.80. So we'll take 0.80. Okay, na? I will check the question bank again. If it is 1.54, I will change that one. Okay. Hello. Students listening to me?
Yes, ma'am.
You understood now? E naught
Yes,
cell,
ma'am.
how much you are taking here in 6th problem?
Ma'am, E cathode minus E anode, ma'am.
Silver electrode potential is 0.80 plus 0.80 and zinc electrode potential is minus 0.76.
1.56 only, ma'am.
1.56, no? Apply that only in the Nernst equation. Okay? Okay. Hello. Understood, no? Answer is this only, ma. 1.40. Just you check once. Hello. Students.
Yes, ma'am. Yes, ma'am.
Check the answer, ma, once.
మ్యామ్
Check the
అది ఆ ఆన్సర్ వచ్చేది 1.54 తీసుకుంటా మ్యామ్.
ఏది 1.40?
1.54 తీసుకుంటే ఈ నాట్ సెల్ అప్పుడు ఈ ఆన్సర్ వస్తుంది మ్యామ్.
Now tell me with 1.56, ma. This last one you do and tell, ma. Now last one you do 1.56 minus 0.0591 by 2 log 0.2 by 0.002. Tell me answer now. I will change in the PPT. Hello, students. You are listening to me? Hello? You have to tell me the answer now.
I'm 1.42.
1.42?
423, ma'am.
391, sir.
39.
9. Yes, ma'am.
Okay, na? 1.4239. Correct only, no? Hello, students. Correct only, no? 6th problem.
Yes, ma'am.
Okay. We finished 6 problems now in electrochemistry. Okay, na? From part C. Now, 7th question is, why does a steel pipe in a large copper tank corrodes and causing rapid corrosion? So what you will write my reason here? Why does a steel pipe in large copper tank corrodes and causing rapid corrosion? So we are taking large copper tank, in that we are fitting one like a small steel pipe. Now steel pipe is undergoing corrosion.
మ్యామ్ లార్జ్ cathodic area, small anodic area.
Large cathodic area develops here and small anodic area develops. So where is the oxidation reaction, ma? Where is the reduction reaction?
Steel pipe ma'am, it goes rapid oxidation.
Oxidation reaction, whereas copper, it will undergo reduction reaction. Okay, so where a small anodic area is there, so that part more corrosion will takes place, means immediately all the steel pipe, it will undergo corrosion. So in presence of large copper tank, you write the reason, mother. Okay, there is a large anodic area develops and small large cathodic area and small anodic area, and severe corrosion takes place in steel pipe. Now 8th question, how is cathodic protection of iron different from its galvanization? How it is different, ma, from galvanization? Both are
Cathodic protection We make iron as cathode by connecting a lower reduction potential metal. But in galvanization, we coat the iron sheet with molten zinc, ma'am, to protect it from corrosion.
So you have to explain properly that one. Okay, na? So when you get this question, how is cathodic protection of iron different from its galvanization? So I have to explain clearly. Okay, na? Next one, 9th one. Galvanized container is not used for storage of food products, but tin coated container is used. Comment on the statement.
Zinc is toxic in nature.
Zinc is toxic in nature, so we cannot use for storage of food products. But tin, you have
Tin
to
is
write.
not toxic.
So since tin is non-toxic in nature, so we are using for storing food and for packing food or cooking food. Okay, utensils also we are going for tinning process. Tin coated utensils we are using for cooking. Now next one, iron does not rust if the zinc coating is broken in a galvanized iron pipe, but rusting occurs much faster if the tin coating over iron is broken. Tell me reason.
Ma'am, even if the zinc coating is broken, zinc is a lower reduction potential metal than iron. So it will only be the anode and it will only undergo corrosion. But tin is a higher reduction potential metal. So it will, iron becomes the anode and iron will undergo corrosion.
Okay. So these four questions are there from corrosion. Okay, now part C, 4 questions from corrosion. You got the answers also. You checked, everybody, you checked, ma?
Yes, ma'am.
You got the answers also. For 6 problems, you know the answers. Okay, solving problems, we solved already. 4 questions also, you got the answers.
Yes,
okay,
ma'am.
from part C, if you learn perfectly this 10 questions, how many marks you will get, ma?
6, ma'am.
Remember that. So first module is completed, ma. Any doubts are there? We'll go for a second module.
No, ma'am.
Okay. So we are going to discuss module 2 water technology, ma. So here also part A, part B, part C. Okay, part A short answer questions, part B long answer. Okay, and part C problem solving and critical thinking questions. So part A. So students, what is hardness of water? Students, what is hardness of water? Hello.
Which prevents the lathering of soap, ma'am.
Which prevents the lathering of soap. Hardness of water is that characteristic which prevents the lathering of soap. So compare temporary and permanent hardness of water. What you will write? Temporary hardness, permanent hardness. How you will
Temporary hardness is caused by calcium bicarbonate and magnesium bicarbonate.
by magnesium
Permanent
bicarbonate.
hardness is caused by chlorides and sulfates.
Sulfates of calcium and magnesium. Temporary hardness can be removed by
Boiling.
boiling. Permanent hardness can be removed by
Chemical processes.
chemical process. Okay. What is the basic principle involved in the estimation of hardness of water by EDTA method? What is the principle? What we are going to use here? What is the principle? When we are adding chemical EDTA to hard water, what is forming in the water? What is the reaction taking place? Complex. Complex.
Complexometric method.
Metal EDTA complex is formed. Okay, no? It is also known as complexometric method. So to the hard water, we are going to add. So I gave here temporary hardness, permanent also. Okay. So we are taking hard water containing calcium and magnesium. So we are adding EBT, aerochrome black tea, which is blue colored indicator. So when we are adding this blue colored indicator to the hard water, so we are getting wine red color complex. So if calcium and magnesium present in hard water, then we will get wine red color complex. If there is no calcium or magnesium, you will get blue color only. Okay, so to this wine red color complex, so to this solution, we are going to add EDTA, ethylene diamine tetraacetic acid, so that here the EDTA, it is reacting with calcium EBT or magnesium EBT and forming calcium EDTA or magnesium EDTA complex, which is colorless stable complex and releasing free EBT indicator, blue colored indicator, so that we will get at the end point, the color changes from wine red color to blue color. Wine red color to blue color. So that is the principle you have read. Asked only in principle, short answer questions. Third one. Define ppm and degree Clark. Tell me ppm.
1 part of CaCO3 equivalent per 10 per 6 parts of water.
1 ppm is equal to 1 part of calcium carbonate equivalent hardness causing salt per 10
per 6 parts of water.
Okay. I didn't give here. PPTs I didn't give in units I didn't give, I think here. No. Here it is. One more it is asked, no? What is that, ma? ppm and fourth question. Degree French, degree Clark, tell me. Students. 1 degree Clark is equal to?
1 part of calcium carbonate equivalent per 70,000 parts of water.
Parts of water. Milligram per liter? Tell me.
1 part of calcium carbonate equivalent per 10 per 5. Sorry, not 10 per 1 liter.
Same like ppm only.
I don't know.
Same like ppm only. This also milligram per liter. 1 milligram per liter is equal to 1 milligram of calcium carbonate equivalent hardness in
1 liter.
1 liter. 1 liter only we converted, ma. In what we can write? What we can write? 10 power 6.
10 milligram of water, ma'am.
I didn't write here, ma. 10 power 6.
Into the power of 6
I didn't write 10 power 6 parts of water. 10 power 6 milligram of water. Okay, na? I didn't write 6 here. Okay, na? 10 power 6 milligram of water. Now tell me again, 1 milligram per liter is equal to 1 milligram per liter is equal to. Hello,
1 ppm.
tell me.
1 ppm.
1 milligram per liter is equal to
1 mg of
1
calcium
mg of calcium carbonate equivalent hardness per 10 power 6 milligram of water. Okay, na? 10 power
6 parts of water.
10 power 6. Here I have to write 6. Okay, na? 10 power 6 milligram of water. Now, one more is there, no? Degree French, I think. Last one. Tell me, degree French. Hello.
One
Students,
part of calcium carbonate equivalent for 10 power 5 parts of.
parts of water. Very good. 4 we completed. Okay. So disadvantages of hard water for domestic or industrial. Tell 2 points.
Domestic is washing.
For cooking, washing, we cannot use hard water. Yes or no? We cannot use hard water for cooking because producing salts like calcium carbonate salt, it will be, we are getting like a white coating surrounding the utensil, inner layer of the utensil. Okay, so we have to apply more fuel, we have to use more fuel for cooking, and time also required more for cooking. Okay, ma. So bathing also it is a problem. Okay, because we are getting like it forms a sticky precipitate with the soap. Okay, so it is also difficult. Drinking also we should not use hard water because we'll get problems. Okay, like forming stones in the kidneys. Okay, and problems in urinary tract. Okay, so there are some problems are there in domestic wise. And industrial wise also we discussed in textile industry.
Sugar,
We
paper.
have to use only soft water because we won't get when we are giving dyes colors to the clothes, we won't get exact shades of the colors. Okay, so there should not be any calcium and magnesium salts in hard water. Okay, so we have to use soft water in textile industry. Sugar industry also we have to use soft water without any sulfates, nitrates and carbonates. So that if these salts are present in hard water like sulfates, nitrates, so it will be here difficult here for sugar refining. Okay, causes difficulties in crystallization of sugar, means it will be deliquescent, means it will decompose immediately. We won't get crystallization of sugar here. So that is the problem. So you write these points if you get disadvantages of hard water. So take some other industries also. Okay, so I explained like pharmaceutical industry, you can take boilers, you can take, and you can explain. Okay, now you take 5-6 industries. Now next. Students, what is soft water, hard water? Compare soft water, hard water. Hello, students.
Soft water gives lather with soap. Hard water does not give.
Does not give lather with the soap. Okay, so you write what is soft water, what is hard water. Okay, if there is no dissolved salts in water, that is soft water. If there is a dissolved salts present in water, that is a hard water. So how do we know that? Means when we are treating with the soap, if lather is produced, that is soft water. If lather is not producing, that is hard water. What is soft water? Give the examples of any two soft water resources. So same thing, students, here you have to write what is soft water, and just you write examples of two soft
Still water and rainwater.
You can write. Okay, na? How permanent hardness is removed? How permanent hardness is removed from hard water? You are taking a sample of water. Temporary hardness you can remove by boiling. Permanent hardness, how to remove from hard water? Any one example? Students, we discussed one method or two methods we discussed.
I'm
Hello.
treating water with washing soda.
Washing soda, okay. Ion exchange process, no? We can remove permanent hardness,
Yes,
no?
ma'am. Ion exchange method.
Reverse osmosis also, no? Yes or no?
Yes, many methods.
Permanent salts we can remove, no, ma, by chemical treatment methods. Yes or no? So write example, ion exchange process, okay, na? Next, list the salts responsible for the temporary and permanent hardness of water. Tell me the salts now. How many salts you know? You tell me.
6.
Tell me that 6 salts.
Calcium bicarbonate, magnesium bicarbonate for temporary.
Temporary. Okay. Permanent salts.
Chlorides of sulfates. Chlorides and sulfates permanent.
Chlorides and sulfates of
Calcium and magnesium.
calcium and magnesium. So calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These are the permanent salts. Okay. So that you have to write.